right? So let's talk about yield for a second, because I think it's important to know. So yield, I think, appeared in, as far as my memory serves, it appeared in C# 2.0, and it actually, like, it gave us this ability that we could have some sort of a stateful, quote unquote, stateful for loop. In fact, it's somewhat like, once you look at it, how it actually looks like in like, once you decompile it, you'll see it's something similar to a state machine. And I'll show you what I mean. So let's say that you have a static I enumerable, and I'm actually going to use the generics here. So I'm going to have an enumerable of int, and I'm going to have I'm going to call this example. Okay, so a normal return doesn't work, actually. So I mean, it could work probably if you say this. So yeah, so this doesn't work, for example, because you are returning an integer, and the return type should be like I enumerable, right? The way you could actually return a 0 is yield return, and it will work. Okay. Yield actually even it actually existed in Windows. I think it was introduced in Windows 3.11 using C++, obviously, and you had something which is called a yield function. It was a yield function, not like the keyword in C++. It's not a keyword in there, but they implemented this concept that you could actually simulate cooperative multitasking with it, or not simulate, actually make a cooperative multitasking, because that thing is not a blocker, actually. You can implement with yield and enumerables, you can implement something which is called coroutines. And it's a very famous programming concept. Okay, coroutines even exist in other, I think you can see it more in the in front end even development. In game development, we use it a lot. In front end, you will see it. In C#, in order for you to implement a coroutine by hand, you get to write a little bit of interesting code so you can have that effect. And what it does is that you don't actually, it doesn't block the UI. So you could actually have something yield that yield returns every time, every certain amount of time, and it doesn't block the main thread, or at least it simulates that. So so yeah, check out coroutines. I think it's an interesting concept to learn about. All right. So what does this even mean? What you could do with this? So let me actually write here. Let's say you could console.writeLine. Actually, you could say for each on this guy. So for each example, and then you can say console.writeLine item. And this is legal because of the because for each works with I enumerables, by the way. So if I hit Control F5 right now, it will give me 0, the 0 which I've written here. If I can actually have this guy return multiple of them. So I can have, for example, here 10, 20, 30, 40, 50, and if I hit Control F5, it will just simply work, right? In fact, this for each loop is something similar to this right now. It's something similar to what I'm about to do. So example, this thing is actually returning so var enumerator equals to example dot get enumerator. Okay, and then you say enumerator dot move next, and then you can console.writeLine enumerator.current. Okay, because your for loop is actually, your for each loop is decomposed or rewritten. If you remember from the lowering, the one which I've shown you the source code for it, your for each loop, basically speaking, it actually gets decomposed into a while loop. And the while loop is using this enumerator while you can move next, because this one returns a Boolean, and you can actually write the current number. So if I hit actually Control F5 right now, it will write to me 10. Okay. The fun part is if I say move next one more time, it should give me 20. This is fun, right? So if you would like to repeat that for loop by hand, you could do actually this, right? So hit Control F5 right now, it will just give me 10, 20, 30, 40. So this is actually quite interesting observation. It seems to be that this thing remembers its state, which is super important. Now let me actually decompose for the for each loop for you. So the for each loop goes as follows. So you basically grab the enumerator of a list or whatever implements the IEnumerable interface. And then what you can do with that, you can actually say while enumerator move next, you can say console.writeLine enumerator.current. This is exactly, let me comment this. This is exactly what your for each loop expands to. So if you have a for each over a list, it will be your list dot get enumerator, and then it will do exactly the same thing. This is how your for each loop actually works. So if I Control F5, you will get exactly the same problem, like exactly the same thing. All what I've done is that instead of me doing it through a loop, I just simply said, okay, I'm going to do it by hand, right? So, oh, sorry. So yeah. And you exactly get the same thing. Now, how does this actually work? Why this is so magical? And again, nothing magical about this. This, in fact, this function will all of a sudden turn into a class with a state machine in it, because you have to somehow remember where you have been. Because if you notice, I call this and I can actually do something else. I can write some code here, do whatever I want, and then suddenly I call this again, and it just simply is still keeping or still remembers the state. So let me actually erase this for a second. Control KC for now, because I would like not to have a lot of fluff in the application. I'm going to Control Shift B that. I will go here and in the bin folder, debug. And then right now here, I'm going to grab my IL spy. And let's see how this guy decompiles. And I put C# 1.0. And if you look, you have, sorry, you have this. This is the example. This is how it looks like. It decomposed, or it actually immediately just got compiler generated, as you can see here, into a class that has a state, and it implements IEnumerable interface, IEnumerable without like the generic one and the non-generic one, the enumerator, the IDisposable IEnumerator. And if you look at move next, the one where we are yield returning, as you can see here, here's my 10, 20, 30, 40, 50. And once you reach the end, you get out. This is how your computer actually remembers the state. So think of it like this. A for loop is a stateless. It doesn't have a state. A for loop, if you interrupt it somewhere, so if I actually go ahead here, and if I, for example, after I write the first item, I just simply say break. Come on. If I say break, if I try to call that loop again, it will start from the beginning. It will never say, okay, I remember my previous state, I stopped somewhere, I will carry on. It doesn't remember that. But this guy, actually, this kind of functions actually remembers. And this is why people use it sometimes for cooperative multitasking. For example, they have some sort of a task that takes a little bit longer time that spans over multiple cycles or multiple seconds, let's say. So they yield return things piece by piece, or they yield return whenever that thing actually has done working. So yeah, so actually check out coroutines whenever you have the time. It's actually quite interesting concept. Okay, so there's one of the bits which I wanted just to stress out with IEnumerables. Now, IEnumerable, of course, it's like right now this you will not see this in production, but let's say you are receiving a list of integers, and you have we call it the list or input, and then you have a for each loop over that input, and then you say input. And then you say if item is larger than, let's say, 5 or 6, whatever, then you just simply yield return that item, right? So it will immediately just keep like returning stuff, as long as it satisfies the condition. Actually, you have, by the way, you have an else statement. For example, let's say if it fails immediately from the first try, you can have actually say something like you have yield break, which actually breaks the whole flow. I think it resets it even, I think. So so yeah, you have that as well to stop all of a sudden like this yielding bit. So you yield return the item, right? And the cool thing about this is that you can keep this somewhere in a list, which you can enumerate over or make a for each over or something like that. But we don't care about using this because, I mean, using this is irrelevant right now. What I would care about is to see how this thing looks like. So I'm gonna reload this, and right now my hello. Did I? I thought I compiled, didn't I? Probably I didn't. Oh, it didn't. Hang on. Yeah, it didn't compile. There was an error. So right now, build succeeded. And if I reload this thing, yeah, right now your thing becomes a little bit more complicated, right? So you have a while loop right now within the actual within your actual state machine, and the more complicated code you have within this function, the more complicated the state machine will be. Now, obviously, this is using yield returns and IEnumerable stuff, like kind of like these kind of functions. They are performance. They are actually, I mean, they are not that bad for performance, but they affect the performance in high performance applications. So if you need to something that executes super fast, this guy actually generates, I mean, this guy will generate a class and will generate a bunch of objects that you need to dispose later. So if you are running this multiple, like if you are calling this several times per second and you generate an object for every time you call this, this will actually become a performance hog. So you have to be careful if you are working with high performance applications. You profile first and you make sure that this is the problem, and then you start at addressing this. But again, high performance applications are a little bit out of the scope here. I'm just simply mentioning it as a footnote, let's say. Okay, so we have so this is the regarding the yield statements and IEnumerables. Okay. Let's see. So anonymous objects, which is perfect right now because we are still with the compilation bit. Anonymous objects, they are, again, you think of them as something that come out of thin air, but they are not. And they are quite useful for making views, right? So if you are having a custom view, or you are generating an object that that's used only once, then, or a class that uses that, you need to generate an object of a class that only can be used once. Then you will actually use anonymous objects. Actually, anonymous objects, I think, introduced in C# 3.0, I think, or if not 4.0, but I think I think it was in 3.0, because in 3.0 we got the anonymous types, the var thingy. I think so, yeah. So what happens with anonymous objects are, for example, imagine that you are in a case where, I mean, what happens was like back in the time, developers had to create a class for everything they would like to have custom made. So for example, if you are making a custom filter crazy view of some sort that you need to dynamically change every time. So for example, like if I get in Paint here for a minute. So imagine that you are having a view and you are generating it based on user input, and you are only, need to make this once. So for example, a user just made a crazy filter which he wants or she wants, for example, an image of a product, a title of a product, and then a bunch of description, right? And then a description here, 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 like so. And then they would like to have also the ratings in stars. So a star here, star here, star here, star there, right? Let's say so. So what you're going to do is you're going to generate an object. I mean, we call it a view object. And of course, it's going to have its own class, but it doesn't matter. But let's say that for a minute here, that this is always dynamically changing. And it's always like people having a different kind of filter. What people did in the past, they had always a class for every kind of view. For example, for every kind of like task they wanted to have, they had to have a class, even though this class is only used maybe once and it will never be used again. So because people had like 100 classes or so, with anonymous object they just simply shrunk it down to like, I don't know, like 10 or 15, it doesn't matter, right? So you don't need to create a class for everything that you would like to create, that even it will be used only once. Maybe even it will not be displayed. Maybe you would like to filter customers, and you are making a custom object that just holds those customers in that format, that another function needs it in that specific format, right? So there are many usages for anonymous objects, and you're going to see them right now actually in the data grid view example. So you can actually see how it behaves. So in order to create an anonymous object, you just simply say var x equals to new, and then you just simply like open the braces, and then you write in your members' names. So for example, if we have a student, it's going to be, for example, ID is going to equal to, let's say, 1, 2, 3, and then you're going to have a name, which is going to equal to someone, and then you have, I don't know, you can have even a list of some things like ints, let's say, where you can have which we call sorry. You can have grades, which is going to equal to new list of ints, and then you can have here 1, 2, 3, 4. The interesting part about anonymous objects is that you cannot modify them. So if you can say x dot, oops, sorry. So if you say x dot, right now you can access these guys. However, they are read only. So you cannot actually say name equals to someone else. Right? This is actually cannot be. And if you compile this and you reload this thing, right now this program is going to have an anonymous type that has been registered in the global namespace for some reason or another. And this is how it looks like. It says private read-only field, and then you have ID, I think, and then you have the name, and then you have the grades. And if you look at the access properties, it's only a getter. You cannot actually set that thing. So you generate it, it's immutable type. You cannot mutate it, you cannot change it. And it implements obviously Git hash code and implements the, I think, okay, this is the constructor, but also it implements the override equals, Git hash code, the dot to string. And as you can see here, the dot to string is implemented in that way. So if I actually go ahead and I say console.writeLine, you'll see these braces. So console Right line. Oh, come on. Did I erase using system? Okay. Console.write line X. Right now I'm going to have this. However, the grades right now cannot be expanded automatically, so it just simply displayed for me the type. Okay. So this is regarding anonymous objects. You can actually just simply generate as much ones as you can, and they are not magical things. Just the compiler will generate for you. As you can see, your compiler generated. It will just generate for you a class which you cannot inherit from. It's sealed class, and you can do all sorts of things to it. And it's actually quite interesting why you would you protect it that way, that nobody inherits from it. And the reason behind it is that you could actually use reflection in order for you to get things from there. Here's the funny part, and which brings us to the dynamic keyword. The dynamic keyword is used in order for you to do interesting operations on types that you don't know what are they. And it is a lot being seen in reflection applications where you use reflection. So let's say you have let's say you would like to know, reflection is actually quite easy. If you say x.getType, and actually if I console.write line this, you get the class, actually, the class name, which you have seen like in the compiler right there. Okay. Now, let's say I would like to know the methods of this thing. So I say dot methods, get methods, there you go. And it will return to me an array of methods. However, I would like to see the first one, dot name. Give me the name of the first method that you have. And this is what reflection is all about. It's kind of what an object can tell about itself. In C++, you can pull this off, but you're going to have to write a very interesting code. I would say like borderline. It's actually complicated code if you would like to pull that off. But for example, all languages that have a runtime, like for example, like C#, Java, Kotlin as well, because Kotlin is using, I think, the Java compiler as well. What else? I think all interpreted, I think all languages that has a runtime, not unlike C++ or something like that, you can actually do reflection. I don't know about Rust though, to be honest. Does Rust has a reflection or not? But anyway, let's hit Control F5 for fun here. And right now you see it's get ID. And this is actually also interesting because if you look at, if I create a class, student, and here I can say public int ID, or let it be so you can actually see it, index, and here email, okay? And we create a new student, so var std equals the new student, right? We don't care about the rest. So if I just simply say this, if I hit Control F5, the first one is going to be get index. And the interesting part here, it's method, which something I've mentioned already at the beginning of the semester. Get and set, both of them, they get actually transformed into methods because these are getters and setters from the old times. So if you look here, you get fields, but these guys, down deep, really deep, it gets converted into a function that just simply returns to you the field. So this get is basically speaking something like this. I'm going to write it like public, for example, string get underscore email, for example, and it gets converted like this, return email. This is what happens when this property gets unpacked. And your set will be public void set email, which will take right now string value, I'll call it val, and it's going to be your email equals to val. right? So this is your set, get, and set, just expand into methods. That's why they appear as a method, okay? And the fun part is you could actually query the whole object. You can say for loop std.get get type dot methods, or get methods, right? Dot length. Right here you can say yeah, exactly, this is what I wanted to say. So let me hit Control F5, and right now you'll get all the methods in there. So you have get index, set index, get email, set email, equals, get hash code, type, and so on and so forth, right? So it will give you all this stuff. Not only that, you can actually even say after it, please give me all your constructors. So you can say, give me the constructor, which you can invoke, which is even crazier. But there you go. You're going to have one constructor apparently, and you have two for those guys. I don't know why. Oh, okay, I probably, I should have said so. Okay, so right now I get two of them apparently. All right, I need to comment this. There we go. One constructor in there. Apparently it's a default constructor, obviously. Okay, so now you know about, at least I told you about the anonymous types, and why would you use dynamic? You would use it because most people just use reflections in order to get the type, or they would like to know more about the object, or they would like to miss and match, like mash a couple of objects into one or something like that. So you have many uses for it. So yeah, this is regarding that point. Let's see. We have one more, which is events and delegates. Now, a delegate is a function pointer, as you already know, and a delegate is actually a type, by the way. So if you define a delegate, which is going to have a signature void my delegate, okay. If you compile this, and if you look at the code here, you will see that that thing, not here, where are you? Program, come on. I'm trying to find the, can't I just see, I remember I've seen it, like, it's an actual type that you can create an object out of, by the way. But as you can see here, okay, fine, I cannot see the full thing here, but a delegate has, okay, it has a signature, obviously, and it's a function pointer, because as you can see here, it has even int pointer. But it has two functions. It has a begin invoke, end invoke for asynchronous operations, but you don't care about these right now. And you have the invoke function, which actually just simply say, please call the function which you are pointing at. This is what invoke is. So invoke, you could write it like, you could say, let me fix that. So you could say, for example, because I need to refer to it, so I'm going to have static here. Or can I actually refer it from here, my delegate? So right now, this is actually pointing to something where it doesn't belong anywhere. But if I say my delegate like this, that means it will call whatever function it's pointing at with that signature. So void and doesn't accept anything. Or you could actually say dot invoke, which gives you exactly the same thing. However, with dot invoke, you can actually check if it's pointing to anything. So you can actually make it like, are you pointing to a null function? No, then you are actually can invoke it. Otherwise, do not, right? So that's a delegate, right? Now, Dennis already have probably explained what a delegate is all about. But there's one more bit I would like to add here. So let's say you have an action. So action is a void delegate, and a func is a delegate which returns something. So let's say an action that takes an int, and I will call this a filter. Okay. And let's say you have a function which says filter, or my filter. And let's say you would like to filter a list of elements. So you have a list of ints right there. And it takes an input. Sorry, let it be like this. List of ints. Oh, wow. Int. There we go. And this guy will have, actually right now, this guy actually, hang on, sorry about that. Func, and it takes a list as an input and gives me a list as an output. Okay. Input. All right. So let's say that this is it. But I'm not gonna talk about this right now. I'm just gonna leave it as is for now. Actually, how about I erase it so I will not confuse you, because I want to show you something. And then later on, I will show you the delegate version. So let's say you are trying to filter something that is filter larger than 5, right? And then you can have, and then you for each over the input. And then you can say if item is larger than 5, then you just simply, you're going to have another list, which is going to be, thank you, AI list.add, list.add item. And then at the end of the day, you just simply return the list. Okay. Obviously, you can write it in many, many different ways. I'm just going to simplify things here. Now, obviously, if I call this, I can say var result equals to filter larger than 5. And then right here, I'm going to have a new list of integers. And then I'm going to give it, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go, which is more than enough for us. All right. And then you can say for each of our item in result. And then you can say console.writeLine result. I control F5. What the? So it takes a list, turns a list, item, sorry. Yeah, happens for the best of us. So at the end of the day, I get 6, 7, 8, 9. Okay, which is fine. Now, the problem is, if I would like to filter this in a different way, and I would like to write, I'm using this in production, and I would like to write this again, and I say I would like to filter this by larger than 6, for example, or something like that, things are going to get a little bit more hairy. It's going to be a little bit more difficult, because right now you're going to have two functions doing exactly the same thing except for this if statement. And your problem is, in fact, this if statement, right? So what do you do in this case? In this case, you would use a delegate. So because imagine that you're going to write 10 functions to compare 10 numbers, and God forbid if these numbers grow, right? So what a delegate will do, you can actually say, okay, I'm going to write in a function that takes in an integer and returns a Boolean, right? And then right here, you can call the function. You can say, okay, actually, the function is going to be called filter. And right here, it will say, okay, the if statement actually requires a Boolean, like a result of a Boolean, right? So it said you are checking equality larger than equals than, if null or not null, a result of a Boolean. That's why we have to return a bool here. So I can say call filter. And then you say item, all right? And then right now you can inject your own custom filter. Obviously, this doesn't work because right now you need to create a function, which is a static void, static bool my filter, or filter larger than 5, right? And this right now is going to be filter list. because it actually does things generically right now, isn't it? It doesn't care about larger than 5 or less than 5. And right here, I'm going to have an integer input, which is going to be 5, value, for example, or item, whatever you would like to call it. And right there, I can actually even, okay, fine. I'm just going to say return item larger than 5. Okay. And this actually should work. So I have to right now inject here filter larger than 5. This guy is a function pointer that it points to a function or method that has a signature which takes an input integer and gives an output which is a Boolean. So I satisfied the condition, right? I satisfied the signature. Right now I'm injecting it here. So if I hit Control F5, it will do exactly the same thing. Now, obviously, because this is actually going to be out of hand, because you're going to write a lot of functions that can be used only once. So people say, no, I'm not going to do this. I can just simply say x goes to, let me undo this, hang on. So I was actually thinking to give you the lambda form. So here's going to be x goes to x larger than 5. So this is going to be a Boolean operation. This is your item. So if I actually just simply say rename this to item, okay? So this is your item. And because it's a lambda form, if I write this in a shorthand, it will be expanded into a method. So if I actually erase this, you will see in a minute that this guy expands into, oh boy, why I cannot see. Ah, there we go. But whoops, I don't know why this appeared. I'm trying to find. There we go. Okay, so they changed how this is actually being generated, but even though I specified C# 1.0, but at the end of the day, here's how your function looks like. Because func didn't exist in C# 1.0, so it actually converts into a class that gives you a function that has this thing in it. Okay, so this is what a lambda actually happens in C# internally, just generates for you a complete function with a class encapsulated in it. And this is one of the things also which you need to know, that this guy is a delegate is a type. So that's why you see it as a CL class right there. Okay. So, and a type which you create an object out of. But this is a little bit advanced. We'll not talk about this. But in any case, this is where you could use a function pointer for, right? Let's see. Now, here's the interesting part. Usually people, like in the books, in the old books at least, when they taught C# about delegates and function pointers, they never mentioned this. They mention immediately talking about about events, right? Now, avoid delegate is just a simple action. So action my method signature. Okay, so that means it's a void delegate that doesn't take anything. So if I would like it to take anything, I'm just going to say it takes an integer. Right now it takes something, right? Oh, by the way, you could actually make this generic by saying t and t right there and t. This will work on any list, by the way. So if I have a list of students, it will work. But you need to say that the filtering item is going to say student.grade, for example, is larger than 5. This is the generic version. And this, by the way, is similar to result.select, but you need to use system.link. So result.select is this guy just a fancy way of writing this. And link is actually working with IEnumerables, works only on IEnumerables. So it's extension functions on IEnumerables. But let me actually first finish the events part. So, so a lot of people can actually use this to stack things. So for example, you could stack my method signature. Do I have to have a static? Can I? Yep. Now it has to be. Now it can be accessible. I can say plus equals, and then I can have x goes to x larger than 5. It doesn't matter. I'm just pointing to a function right now. Actually no. Without a return. So it's going to be var I equals to x equal to x. It doesn't matter. Which should be actually working. So there you go. So this is the lambda way of writing a simple function, right? And then you can do this like so. And you are simply stacking a call. So if I say actually, how about I do actually a console write line? So console dot write line x right here, and I say console dot write line x plus plus. And right here I can say console dot write line x minus minus. Doesn't matter, right? And then you just simply invoke that thing. So my method signature dot invoke, and then you say invoke 5. Or you can say just call it like this. Okay. And if I hit control, if I hit control F5, oh yeah, of course I need to forbid this guy from here. So let's see. Yeah, it invoked everybody. I think I should have done it that way. So if I control F5, now it works. Okay. So as you can see here, you can stack things. Now people were asking, like, what is the difference between this and this? Because practically speaking, you get exactly the same thing, right? And the difference is that with events can be invoked only within the classes that has been registered as. So if I actually have this here, and if I say, and even let it be static, and if I say here student dot that, I don't know if it's a good idea. I don't know if it's even possible to do that. Encapsulated data, public. Right now it's much better. Okay, so if I say student, right, and student dot, this will be illegal because an event can be only invoked. So you can only run it from the class where it actually has been defined. And you can only register to it and subscribe and unsubscribe from it. So you can actually do this and, for example, this. So you can do those two things, right? The same thing with the delegate, but you cannot actually call the event from here. The event has to be called from here. So based on some certain things that has happened, you can actually call the event. And I highly doubt that you can even say this. Let me see. You cannot actually do this. You cannot set it to null, right? So this is the difference between using a delegate, an event, and a just simple delegate. A delegate will allow you to do more different kind of things, but an event will give you a more streamlined multicast, something which we call multicast delegates, where if an event happens, just will cast it everywhere. You can subscribe and unsubscribe from it, but you cannot do some crazy moves like assigning it to a null or invoke it even from here. It is not limiting, it's a design choice, and you need to design your applications in that way. This is the correct way, actually. Okay, you can use delegates without events for other purposes, right? So like this, for example, here you don't need an event, here you need a delegate, actually, right? But for example, in this case, if you would like to have an event that something happened when some students actually has been added somewhere, and you would like to trigger an event, hey, a student has been added, give him his email, generate an email, generate a password, generate blah, 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 and all that stuff. Right now, you need an event for that, okay? All right, because I'm gonna actually finish a little bit earlier here, let me actually get the dedicated view on. Do you have any questions, by the way, so far? All clear?
Yes, yes.
Okay. So yeah, let's go to data grids. Actually, today's class was a very hands-on class, actually. So to be fair with you, so there's nothing much happened. Like when it comes to Windows Forms, except for I'm gonna need to create a new Windows Forms .NET Framework. Also, please remember, a lot of you, I've seen this a lot in the classes, like people creating okay, Windows Form app, which is .NET Framework, but then the class library is not .NET Framework, it's just class library, which is using .NET 6. And the problem is they cannot include the .NET 6 app within the Windows Forms app. Either the Windows Forms app has to be .NET 6, I don't know if it actually exists here in my case, or I don't know if it exists from in the first place. Let me see. Windows Forms. Yeah, so probably this one is actually a .NET 6. But if you're gonna do that, you're gonna do that with a class library, which is the .NET 6 as well, but not a class library which is but do not mix and match. It will not work. The application will not allow you simply. Okay. So I'm gonna have a Windows Forms. I'm gonna hit next. I'm gonna have listing data grid views. And I'm gonna actually keep it very simple here. One of the tasks which I've actually given was you have an in-memory DB where you're gonna actually add a new project class library, and I'm gonna have here in memory or VLMS, let it be so, and then you have right there in memory, yes. DB doesn't rename the file, does it? Okay. And right here, it's going to be a public static class, so you cannot create an object out of it. And then you can have a public static list of students, which you're going to generate in a minute here, which I'm going to call the students, get and set, equals to new list of students. And right now I'm going to have, actually, no need, like so. I'm going to have a new, sorry, it will not work, add new class, there we go, which is going to be student. I'm going to have another class, which is going to be Priii. And both of them cannot be internal. It has to be public because I would like to address them from outside. Internal will be quote unquote private within the namespace. So it will be only visible within the current namespace, but outside of it will not work. And I've seen a lot of people actually have like missed that out. So please be careful. So public static, or sorry, not public static, public string index, and then public string name, and ctor. And actually, I don't need a constructor here. And what I'm gonna do here is gonna be a public list of subjects or predmet. I'm gonna call this predmet. It's a horrendous design choice, just to be clear here. But I'm trying to keep things simple because I wanted to drive some point across here. So public int odsina was getting set, and imash naziv predmet. Oh, so we have a string naziv getting set. I'm just trying to figure out, or like trying to make up something really quick here without any issues. So right now we would like to get a new list of students. I'm just gonna, I mean, without even generating or anything, I'm just gonna dump things right here. So new student, which is gonna have index, which is gonna equal to 1, 2, 3. Name, which is gonna be, I don't know, gonna be Dennis for now. And then a list of subjects, right? So it's going to equal to new list of predmeti, which is going to have within it even some subjects, right? So you can actually have something like this. So I can make this a little bit more neat to read, even though it is a horrible way of writing things, but hopefully you won't mind, I guess. All right, so this is a student and comma. So I think it would be best like this. And right now here, I'm going to have naziv predmeta. Sorry, new predmet. And then right here, you can have naziv. And then we're going to have, for example, pair 3. Odsina equals to 4, maybe. Right? And I'm going to add 3 subjects per student. Whoops, sorry, I need to have comma. And there you go. So right now we have another subject, which is, hang on, let me put this new student, semicolon here. Okay, so let it be here. KGR, Mathematica, and here let's say 5, 7. And I think it's a good starting point. So right now I can duplicate this guy right there. And just have 3 students with each subjects with 3 subjects each. And there you go. And here we're gonna have, for example, I don't know, Yasmin, and then we're gonna have Brian, and then we're gonna have, let's say, so per 2, например, UBP, for example, whatever, or programmera UPR, let's say it's gonna be, let's say 8, and let's say there's gonna be 7. AI, whatever you would like to call it, and this is here is going to be Hathi, for instance. Here is going to be, I don't know right now, digital logica, for example. Here is going to be SPA, and then we can have here 9 and 10, for instance. And we are good to go, right? So we have a bunch of students. I just simply generated some data because I needed to work with it. Okay. Again, not the best design in the world, but just I need to demo stuff. All right, so let's say we have a data grid view. Why the heck? Come on, be normal. Now, I've actually demoed a lot of features of data grid view. I'm not actually going to make anything special about, like, I'm not going to add anything specific about this, but I would like to. I actually gave a task to the students this today, and let me give you like it actually was like in 2 steps rather. So so I actually told them that I would like to select a student from here and show the list of subjects here. However, I would like to be able to filter the subjects as well. So in one go, I would like to see all the students. If I click on a student, I would like to get all the subjects for the student who actually passed, had a grade larger than 5, so 6 and above. Right. So if a student didn't pass any subjects, if I click on the student, he should be actually not having any subjects in there. Like it's almost nothing in there. Okay, so that's one thing. Now, but then later on, I actually told them like, okay, make this as a combo box. Put a combo box here, which I can filter the grades. This is similar right now to exam questions. You're gonna have a combo box. You click on it, you filter things in several occasions. I'm keeping this in a single form. In an exam, you can have multiple forms, but more on that later. So I'm gonna call this data grid view student. Come on. What is the name? There we go. So data grid view students. And this is data grid view predmet. Mixing and matching languages is awesome, as you can see here. CMB Otsine. Might be so. And let it be Hamawak. There we go. So we can be like a little bit more consistent. Give me a second, just all right. So so let's say on form start, on form load, we would like to filter all the students. So let's say I would like to say, okay, data grid view. Sorry, we cannot access the students from here. We need to add it as a reference. So add reference LMS, and then we say in memory DB dot students, right? I can say data grid view of student equals to the data source equals to that, right? And if I hit Control F5, right now I get the students. However, the list of the subjects do not appear, by the way, because data grid views are actually quite confused about it, right? How can I actually map an array to a cell, right? It cannot do that. You need to actually give the data grid view something that it can actually work with. Now, a lot of people, when I actually given them the task, how to filter a list using another list. So we had something like var result equals to in memory db dot students. Actually, they actually said like some of them written it in this function form, and some of them written it in canonical form. So they said from std in students. Sorry, in memory db. And then they had another one, which is from PR in std. Why on earth? There we go. std.predmeti. And then they say where pair larger than pair otsina larger than 5, right? All that dot to list, right? Some of them actually did that way. So for example, like if I grab this, did I forget something here? I usually don't write it that way, but hey. Why do I have an error? Well, okay, fine. Select std. I thought that I actually did the selection at the beginning, which is fine. So select me that student. Okay. Now, obviously, I think I will not have. I'll select this. Actually, select like this new. And right now, I'm gonna have std.name. Actually, it's gonna be name equals to email equals to std.name. And in fact, I'm gonna have here index. std.index. And at the end here, I can actually have here, I don't know, std predmeti jednako std.predmeti. I don't know how it will look like, honestly. I cannot remember how they got it at the end, but let's say something like this. Yeah, and at the end of the day, I'm getting repeated stuff. So if I actually like make this better, so I can say, let me make this better. So they got something like this. Nazif predmeta equals to pair dot nazif. I onda naziv, onda nije naziv, odnosno ocjena equals to pair.ocjena. There we go. And if I hit Control F5 right now, I'm going to get the subjects, which he passed, and then it's actually kind of repeated. Now, obviously, you shouldn't have this, but this was like kind of a task which I wanted to force them to think about using anonymous objects and filtering a list with a list. This is a very horrendous, this is very bad example, but because I think it should never happen in reality. Maybe it could happen in reality, which is normal. Okay, fine, but I think it's not a good idea. But at the end of the day, you get a demo of filtering a list with a list and having more of these things, like having more filtering a list with a list and having more data just displayed in one place. Now, and then I said, okay, let's actually do this this is what we call the canonical form, by the way. It's written like this. This is linked to objects, by the way. So what we did here, using like where.select and these stuff, this is what we call link to objects. Now you have var, what we do from now on, by the way. But this is called canonical form. You have var result 2, which is going to equal to, I think, if my memory serves right, in memory db.select, in memory students.select, and right here you can actually write in what you want. So x goes to x, actually std, and then right now you can say new, and then right here you can write in. So std dot name. So std, actually right now you're gonna have to write in this stuff. But without the other ones. So I cannot remember honestly how I've written this. Let me see. Oh yeah, I need to remove additional curlies here, additional curlies here. So ehsad, oh yeah. You're gonna have here predmeti is gonna equal to std dot predmeti dot, and then right here you can have where. Let's say PR goes to PR dot ocjena is larger than 5. And right there, you're going to actually convert it to a list. And all of that stuff is going to be converted to a list, I think. Or the problem is I lost track right now of stuff. Hang on. I mean, obviously, you shouldn't write it that way at all, by the way. Dot to list. This is a very, very long way of saying things. But I think this is the way to convert it. So if I have actually here, right now things will look a little bit weirder. I mean, it's going to be the same, obviously, because I didn't include I included the list. But for the second task, which I've given them, I told them that data grid view of pre-enmity.data source equals to result dot yeah, right, because I actually have made this like so. Right now it's a bunch of anonymous objects actually. I should have actually filtered it in a different way, but hey. Let's see. There's actually a different way of filtering it. Hang on. I give you some sort of an equivalent to the canonical form. I just need to remember. This. Let's see. This index. I actually probably shouldn't have a new one like so, because it's going to be actually difficult to get for every student. So let me actually show you this. So if I actually have, I can actually have a new student, to be honest, where you have the index, you have the name, and you have exactly the same thing, right? But whenever you click on that, this is actually the next task, was it? So if I had, oh, sorry, I didn't want to do that. I didn't want to do that. So if I had F4 here, I need an event on cell click. Where is cell click? And one of the things which I need to enable though is a full row select, which is a selection mode, I think it's called. For row selection or something like that. Hang on. Column, visible cursor. Why can't we search here? It's going to be kind of funny. You guys already see it like since a long time ago, and I'm trying to find. There we go. Full row select. There we go. And so if I click on a row, it will give me the whole thing. And I can say, because this data source has been assigned to a bunch of students, okay, so I can say that data grid view predmeti dot data source is going to equal to the cell which I've clicked. So if I actually have var std equals to var selected student equals to data grid view of a student dot selected rows of 0, because I'm going to select only one row. Probably I need to disable multi-select there. Hang on. And I'm going to say, it's going to say data bound item, because if you don't do that, you will not actually get the student. And right here, I can say, they're going to use cell click. You have something which is called multi-select. I think you have, it's a true false thing. Show cell error, show the data, wait for cursor, allow. Multi-select, false. You will always have one single row in there. Okay. And right now, if I say, I can actually say data grid view pre-enmity dot data source is going to equal to this. There we go. Perfect. So if I hit Control F5 right now, if I select this guy, it will give me only Mathematica, which is larger than 7. This guy actually has passed more, and this guy has passed more. Probably I need to say read only as well, so you cannot modify this thing, because it's kind of annoying to click around. So I think enable edit or something like that should be disabled. Allow drop, allow user to add order, size. Can I say read only? True. There we go. So you cannot actually edit stuff. There we go. Okay. So right now we are filtering this, but I would like to filter from here as well. Okay. So let's say I filtered once, and I will leave the filter in there, the built-in one. And if I say, okay, here I'm going to add, so 6, 7, 8, and 9. Even though I could fill it and 10, there you go. So I would like to get all the students who got 10, let's say. So this one, and if I let me see, do I have it? Okay, perfect. And I'll make it actually read only, so nobody can drop down style is going to be drop down list, and right now you cannot edit the text in there. So if I run this, you will not have. Oh, I shouldn't actually add the comments in there. Okay, sorry about that. Be like so, so take this out everywhere. There we go. I say okay. Do we have a default? I think there is a default value to be selected index or something like that. It should be like the first one, but doesn't matter. We will look at this later. So if I actually select index change, so I double clicked on the thing. So if I get a grade, all what I can do, or everything, like it's actually super easy. What you could do is you could make this public, or sorry, like public, like a field. So private students, or private list of students selected, or actually, yeah, actually I need the student actually, so select the student. Let's say so. I'll put him here. I don't need this. Put this guy here. And then here I can just simply say, from the selected student, if I have one, so if selected student doesn't equal to null. So if I have actually, like, as if I started the application, and somebody just filters immediately without selecting a student, you could have just simply like check if it is not null. If it is not null, so I can say select a student dot predmeti dot where, let's say, right now I'm gonna have so simply like CMB ocene dot selected item, and then I will cast it to end. So x goes to x dot ocene. Let's say larger than or equals, or equals selected item, and I will cast this to an integer, because simply this is actually just a bunch of integers, right? And all of this is assigned to a data grid view data source, which is this guy. And the result is going to be converted to a list. And let's see. So right now, if I select this guy, for example, I give 787, and if I say give me the grades of 7, oh boy. Okay, hang on. Let's see. Probably I forgot something. 7. Oh, sorry. Yeah, obviously. Because it's a string. Yeah, yeah, fine. End.parse this guy. Actually, if I filled, there we go. if I filled the combo box with a list of integers, if I said that at the beginning of the form, so here's the problem. If I said actually CMB otsene dot data source equals to new list of integers, which is going to have 7, actually 6, 7, 8, 9, and 10, and I assigned it that way without filling in this thing there, it will actually detect it as an integer when I cast it, because this thing returns an object. But because I filled it in there by hand, and right now I have a bunch of strings, I have to cast it that way, right? Which is kind of sucks, actually. I don't want that. So let me actually like remove this thing. Let me delete that. This actually, I hate this. And I'm actually gonna be having, yeah, I'm gonna leave it there. And I'm gonna just simply cast right now. Yeah, sometimes when you just go ahead of yourself. Yep, that's it. Solid 5, I think. And yeah, so right now I have a default selection, so it's there. If I select something with a 7, we should get 2 7s right there. So if I actually select this guy and I would like to select, let's say, 10, it will give me all the subjects that has 10 in it. Okay. If you would like to keep the filtering happening, so for example, on every selections of the student, you can just simply say on cell click, and then you can say this. If you would like to keep that filter active, you can simply put in sender and E, and you are done. You are propagating the event. So if I hit Control F5 right now it's 6, then it's never had one. Yasmin, 6, nobody has 6s. So let's see 7. All right, let's see 10. Somebody only got 10. All right. So, but this is me like trying to force this propagating event based on the selected stuff in the combo box, right? So just based on that, I just simply like, as if I'm causing a change in the selection. So this is the part about link, the thing which then is covered. Here's the query form. There's this the function programming kind of call. Even though I hard-coded that thing here, you could actually just simply change it with a combo box if you want to, instead of me just doing this again. So right now you could just simply like ignore that result 2 altogether and just simply fill in that with the students. So you could just simply say like so, right? And it will work pretty much the same. Let it be 10. There you go. Here's 1 is 10. 8. Somebody only took 8, 7. Yeah, there we go. So yeah. I think in the classes I've given these tasks to the students, like 2 data grid views and a combo box, and change things and filter things out. And they were actually trying this by hand. I think this is it. So I'm gonna actually stop recording.